All right, hey guys at home. So we will go ahead and get started. We're waiting on people to pop in through the lobby, so bear with me as they start popping in. Today is not going to be a super long day. We're going to look at acids, bases, and salts. Today we're going to start off, we're going to do a real quick, sorry the hiccups, review of naming acids. So remember there were special naming rules dealing with acids. And then we're also going to look at properties of acids. We might go a little bit further just so there's not as many notes for Monday, but we're not going to kind of start with the calculations yet. And then we'll do a kind of quick review or recap of things that are going to be on your quiz tomorrow. And then I'll kind of set you guys free. Remember, your part 1 homework was due yesterday. No. Yeah. Today's Thursday. Part 1 homework was due yesterday. Your liquid capacity of Penny Lab is due today. I'm still missing about half the class worth of homework. So make sure that you're kind of getting that stuff taken care of and turned in, because we only have a couple weeks left. It's going to be very short. So looking at acids and bases, so like I said, we're going to do a quick review of naming acids first. Remember, acids contain one or more hydrogen atoms and will produce hydrogen ions whenever dissolved in water. And an acid has an anion combined with as many hydrogen ions needed to balance the charges. So remember, acids always started with hydrogen. So we had hydrogen and then some other substance that it was paired with. So anytime it started with hydrogen, we could consider it to be an acid. So remember, what identifies an acid as being an acid is it does start with hydrogen, and only that hydrogen at the beginning can be given up to produce those hydrogen ions. So if we had a polyatomic that had hydrogen in it, that hydrogen would not do anything. It's only that first hydrogen that can be given up. So the chemical formula is normally that H to the HX. And since hydrogen's a positive one, we're never going to add subscripts onto that anion, but we might need more than one hydrogen to balance out those charges. So remember, these do behave like ionic whenever you're writing their formulas. So the N tells you the subscript of how many hydrogens you need to balance the charge of that anion. Remember, whenever we're naming acids, remember there were 3 different rules to name acids depending on what the anion ending was. So if the anion ended in IDE, so these were the things right off the periodic table, or the polyatomic cyanide. These we use the prefix of hydro, the main part of the element name, and then it's going to end in ic acid. So our general rule was it was hydro, whatever the main part was, ic acid, whenever we were naming these. So for example, HCl, the Cl is chloride, so it does end in the IDE. So whenever we would name this, it would have that prefix of hydro, the main part of the name, so the chlor, and ic acid. One thing that is true about acids is they are going to be aqueous. So these are dissolved in water to produce those hydrogen ions. Our next example we have is the H2S. This we're going to treat the same way. S is sulfide with the IDE. So we're going to use the exact same pattern where we're going to have the prefix of hydro. And then it's going to be sulfur. That's one of the ones that kind of regains its original letters. And ic acid. And it kind of does that because if it was hydrosulfuric acid, that kind of sounds weird. But the hydrosulfuric acid would be the name of that one. So you're only going to see that hydro whenever it's this rule with the IDE ending on the anion. Right, so any questions about the first acid rule? Hopefully this is coming back a little bit. So our next acid rule dealt with our other anion endings. So these are going to be from our polyatomics. So whenever we have a polyatomic that ends in ITE, whenever we're naming it as an acid, there's no prefix. There's only a prefix on that first rule. So this is going to be the main part of the name. And then it's going to end in us, acid. So no prefix unless it's that IDE rule. So here I have the example of H2SO3. SO3 is sulfite with the ITE. So we would name this as the sulfur acid. We could also have something like HNO2 would be another example. NO2 is nitrite. So this would be nitrous acid. And then our third acid rule is with the rest of the polyatomics that end in ATE. This is very similar to the first rule, but yet again, no prefix. So this is just going to have the main part of the anion name and then end in ic acid. So identical to the first rule, just without the prefix. So here we have HNO3. NO3 is nitrate with an ATE. So this would simply be nitric acid. And then if we are writing formulas for acids, we can kind of use the same rules, but go the opposite direction. So look and see if it has a prefix or what ending it has to figure out what anion it would be. And these are just like ionic compounds where you have to balance those charges out. So let's look at going the opposite direction. So whenever we're writing formulas for acids, we're using the same set of rules in reverse to let us know which ending we have. And then we're going to crisscross our charges to write the formulas. So if we had hydrobromic acid, so it has that prefix of hydro, so that's how we know this is bromide. So remember, bromide is off the periodic table. It's Br. It's in that group 7A, so your halogens, so it has a -1 charge. All acids start with hydrogen, which has a +1 charge. So whenever we balance our charges, there's just going to be one of each. So it's going to be HBr. And remember, these acids are aqueous. Okay. We also might have something like phosphorus acid. There's no prefix, so we know it's not the first rule, but it ends in that OUS acid, which means this is phosphite. Phosphite is one that's not on your reference sheet, so you wouldn't normally need it, but there's only so many things that end in ITE. Phosphite is PO3 with a -3 charge. All acids start with hydrogen. So if we kind of balance our charges, we would need 3 hydrogens and only one of those phosphites. And remember, acids are going to be aqueous. Same kind of deal goes for our last one, carbonic acids. There's no prefix, but it ends in ic acid. So that kind of tells you that this is carbonate with an ATE ending. So carbonate on your reference sheet is CO3 with a -2 charge. Since it's an acid, we know it starts with hydrogen. And whenever we kind of crisscross and balance our charges, we would need 2 hydrogens and 1 carbonate. And acids are aqueous. So that was kind of a review from unit 4 or 5. I don't remember which one it was off the top of my head. So it's been a while since we've kind of used these rules, but I wanted to kind of refresh you and make sure you're familiar with these, because these are going to come up a good bit through this last part of this last unit. We're going to be dealing a little bit more with classifying acids and bases, calculations and stuff, but I wanted to kind of refresh you on those acid rules. Remember, I didn't put bases on here, but remember, bases have hydroxide, and they're named just like other ionic compounds. They didn't have any special rules that we had to follow with bases. Sorry. All right, one thing that we're going to look at more this unit as well is properties of acids and bases. So this may be something completely new for you guys. You may have dealt with acids and bases a little bit in middle school, but it's been a while, no matter when you dealt with them. Acidic compounds give food, gives food a tart or sour taste. So think of like if you have something with vinegar, lemons, or citric acid, like juices and sodas. Sometimes it has that kind of tart or sourness to it. Makes you kind of scrunch up your face a little bit whenever you eat it. Acids cause a color change when combined with chemical indicators. We are going to do an indicator lab on Tuesday. So you'll kind of see the different colors that they change. Big ones to know, indicator-wise, there's litmus paper. Litmus paper are like the little pH strips that you might have used before. And with acids, they turn a red color. So that's one that you may have used before, where you take the little pH strip, dip it in there, and look at what color it changes. An indicator that you may not have used before, and this is one that we're going to use in that indicator lab, is phenolphthalein. And don't worry if you can't spell it. Phenolphthalein. This, whenever it comes in contact with acids, is actually going to be clear or colorless. And there are other indicators. There are actually probably over 100 different indicators that we could use. But these simply change color at different pHs. So we're going to be exploring kind of using some of those in our lab on Tuesday. With acids, acids act as electrolytes and can conduct electricity. So we already said acids are aqueous. So whenever something ionic is aqueous and in water, remember it splits into ions. So since there are ions there, it can conduct electricity. You might be a little bit more familiar with this, like if you drink Gatorade or Powerade or something like that that has electrolytes. It basically is slightly acidic, but it has those ions floating around to replenish them within your body. Because whenever you sweat and stuff, you deplete some of those ions. Yeah. And with acids, whenever you combine an acid with a base, it's always going to make water and some ionic compound, which is a salt. So acids and bases can neutralize one another. We're not going to be able to focus on that too much this semester, just because we are kind of winding down and short on time. But acids and bases can neutralize each other and react to produce water and salt. And I think everybody's with me. All right, and then on the flip side, so looking at properties of bases, bases have more of a bitter taste. Something like milk is slightly basic, things like that. Most bases are actually hazardous to taste. So a lot of times things that we eat are not going to be very basic. One thing that's kind of come out lately is you may have seen like alkaline water and stuff like that. That is slightly basic water. So that can be used to a lot of times neutralize the acidity of your stomach and things like that. Bases are going to have a slippery feel. So like soap is slightly basic. Or if you've ever like cleaned the sink or cleaned the bathroom and you use like Mr. Clean or Grease Lightning or something like that, a lot of times it may leave like an oily feel on your hands, kind of a residue. That's because it is very basic. Bases produce a color change with chemical indicators as well, just like acids do. But our two indicators, so I'm just going to write this up above. So with the litmus paper, the pH strips, bases tend to be blue. So like a green to a blue color. And then with the phenolphthalein, it's actually going to be like a hot pink color, like a fuchsia is what color it will turn. Phenolphthalein, this is something that they'll use if you've ever watched crime shows and stuff like that. This is one of the things that they'll use to test for blood and stuff like that, because our blood is slightly basic. So whenever phenolphthalein is sprayed on something that had blood on it, even if it's cleaned up, it'll kind of turn hot pink. So that's one thing that they use kind of in crime detection to find blood. And the last sentence is pretty much the same as on the previous one. When bases react with acids, they neutralize, producing salt, so some ionic compound, and water. So something like you might have bleach in your house. Bleach is very basic. So if you've ever gotten bleach on your hands while you're doing laundry or something, it's very slippery and kind of greasy. I'm going to keep going a couple slides just so we have less to do on Monday. But one thing that happens with water is water can ionize and produce those hydrogen ions and hydroxide ions. So if there's two water molecules that are combining, it can actually self-ionize. So water doesn't have to be mixed with anything else to produce those ions. So we can have liquid water that produces the hydrogen ions and hydroxide ions. And water, if you kind of remember from middle school and stuff, water is neutral, which is a pH of 7. And any aqueous solution where the hydrogen hydroxide are equal to one another will be neutral. So it is possible to take something that's not normally neutral, alter the hydrogen hydroxide to where the two values are equal to one another to make it neutral. So that's what happens whenever we mix an acid and a base together, is they kind of cancel out until hydrogen hydroxide are equal, and resulting in a neutral solution. And here's where we're going to stop, because I don't want to do the math today. We're going to do all of the math on Monday. So we're not going to do this last slide. This is where we'll pick up on Monday. Monday, make sure that you do have a calculator handy. Feel free to also have a reference sheet. All of the formulas for acids and bases are on your reference sheet. So you don't have to memorize any formulas. It's just being able to use them appropriately. I am going to switch over and do kind of a quick recap of a review of what's going to be on your quiz tomorrow. I do want to show you your homework. So your part 2 homework is open in Canvas. This is not due until next Thursday, I believe. It might be Wednesday. Let me double check the calendar so I don't tell you wrong.
I think it's the walk. Because I tried to click on the calendar and I click on
Let me see. All right, it says it's published. I don't know if you need to refresh or not. Oh, because I'm in second period, that's why. Sorry, my bad. I was in the wrong class period. So I'll unlock it for you guys and then we'll walk through it. There we go. All right, so now it's open for first period. And the homework is due next Thursday. So this is gonna have a little bit of time. The portion that you know how to do, so the very first part of this is classifying things as acid or base. You know how to do the first 4. 6 and 7 we're not doing until next week with types of acids and bases. If you look ahead in the notes, you can probably figure it out. But that's pretty much all on the homework you can do so far. The rest of it is stuff from types of acids and bases and calculations, which we're doing Monday. So you can't really get a good start on this yet. But that is open if you want to go ahead and do those 4. That is available to you. Kind of looking on the calendar. So remember, you guys have your quiz tomorrow on all the part 1 stuff. That will count for your attendance. It is, I believe it's 10 questions, some multiple choice, some of the short answer calculations. So there will be you will be kind of submitting into Floop like you have before. It should only take you about probably, I think the time's set for like 30 minutes. It's not going to take you a ton of time to do. It's very short. Looking ahead to next week. So we're going to do all the math notes, the pH calculations on Monday. I know I'm missing some people for AP World on Monday. I don't remember if that's the morning or the afternoon. Just watch it whenever you can if you have an exam. Tuesday, we're going to do a lab on indicators. That is going to take a little bit longer than the lab we did yesterday. It may take most of the live time, but we'll stream just like we did for everything else. We will finish up notes completely on Wednesday, looking at acid-base types. And then we'll do a test review, a quick review on Thursday. And your homework to do next Thursday, and then your test will be that Friday. The following week, we're strictly going to be doing, there will be some review stuff posted. People will be doing makeup work. In terms of exams, remember, first period exam is Thursday the 20th. So go ahead and kind of put it on your calendar. We'll probably do a little bit of review, but you may have time to finish it in class. It's going to be all multiple choice. So it shouldn't take you a ton of time to get through. And it is a teacher-made exam. So we made it based off of what we got through in class. So some of the units that we had to skip or content we took out is not on the exam. So you don't have to worry about that part. I know I have Kincaid's 4th period is in here. The 4th period exam is going to be on the 26th. So go ahead and kind of mark your calendars for that. Going back to recap, so the quiz tomorrow is just covering part 1 of the unit. So the stuff that was on the part 1 homework. So I would go back and look at water. Remember, water had some very special properties. We talked about water having that bent shape, and it's polar, and it created hydrogen bonding between water molecules. So because of those things, particularly the hydrogen bonding, that's where it had really high surface tension. It had a low vapor pressure. And that's why whenever water freezes, because the hydrogen bonding and the way it locks up, it traps air within the molecule, which is what makes ice less dense than liquid water. So that's why ice floats in water. All the special properties of water are going to be due to those hydrogen bonds overall. We talked about, remember, surface tension was where the pull of the particles is being pulled in towards the middle of that droplet. Every liquid has surface tension, but water not only has surface tension, but it has those hydrogen bonds, which gives it a stronger surface tension overall. With surface tension, if you added a surfactant, that decreased the surface tension. So that's what you kind of saw in lab yesterday of whenever you were using like the soapy water versus just water, you shouldn't have been able to fit as many drops on the penny because it contained a surfactant. Those hydrogen bonds were broken and not as strong. Therefore, it couldn't hold together as well. Vapor pressure, remember, looks at how easily something vaporizes. Something with a low vapor pressure like water is not going to evaporate as easily as something like alcohol that would have a higher vapor pressure. In terms of solutions, remember there were 2 parts of a solution. there were the solvent and the solute. The solvent is what is doing the dissolving. So that would be like water is kind of a universal solvent that we use. The solute is whatever substance goes into the water to be dissolved. Solutions, in terms of making solutions faster, it can be stirred, heated up, or smaller particles in order to make it dissolve better or faster. So that's where we said, like, if you dump sugar into tea and don't stir it, it's just kind of going to settle at the bottom. You have to stir it to make it dissolve. We also talked about hot tea dissolves sugar better than cold tea does. The little sugar grains are going to dissolve better than sugar cubes overall. In terms of solubility, remember this looked at how much could dissolve in a given amount of solvent. So that was dealing with our solubility curves in that graph as well. Remember, a saturated solution has dissolved all it should be able to at that temperature. We also end up with unsaturated solutions that have dissolved less than they should be able to. So if you add more to it, it can still dissolve more. In terms of factors affecting solubility, remember temperature is our big one. As temperature goes up, solubility goes up, with the exception of gases. Gases are affected by temperature and pressure. We can also heat something up to make a supersaturated solution, so we can make it dissolve more than it should be able to. And that, whenever it cools, some of it solidifies and crystallizes. So that's, we talked about, that's how they make rock candy, where they heat the water with the sugar in it, put the flavoring and the coloring, and as it cools down, all those crystals form on the sticks or the string, whatever you're making rock candy on. So you will have problems asking you to read a solubility curve. So we spent a good bit of time on this. That was that first part of your part 1 homework. And pretty much if you could successfully get through the homework okay, you're going to be fine on this. So it might be asking you how much is soluble, how much can dissolve at a given temperature. Remember, each line is a different substance. It might ask you what temperature it needs to be to dissolve this much. It could ask you if the solution is saturated, unsaturated, or supersaturated. So that will give you both the temperature and the mass. And you want to see that point, where is it in comparison to the line for that substance? Remember, if it's on the line, it's saturated. Above the line is supersaturated. Below the line is unsaturated. Also on the part 1 quiz are going to be your calculations for molarity and dilution that we did on Tuesday, maybe. So remember, both of those formulas are on your reference sheet. So you have the formula of the molarity equals moles over liters. So people were doing pretty good with that. Remember, make sure you match up your units. So if it gets you grams, change into moles before you plug in. If it gives you milliliters, change into liters before you plug in. It will also have problems regarding the dilutions. Remember, that was using this formula off of your reference sheet. That's where you have the same substance and you're either changing the volume, which changes the molarity. So this is the one where if you have 2 of the same variable, it's going to be a dilution problem. So it's that M1 V1 equals M2 V2. So that's pretty much everything that's going to be covered on the quiz. I just wanted to do a quick recap. So the stuff that we did today is not going to be on there. That will come whenever we do our test next week. So you guys have the rest of the period. Like I said, your part 1 homework was due last night. So if you have not turned it in yet, go ahead and get it turned in. That way you don't lose as many points. Remember, your liquid capacity lab is due today. So you have time to finish that up. And then you can do those couple problems on the homework of the part 2. But the quiz tomorrow should only take you about 30 minutes, if that. Do make sure anytime there's math stuff, show your setup, show your work. Don't forget to submit your short answer and Floop. And I will see you guys back on Monday. All right, my guys at home, you're welcome to log off. And I'll see you Monday. Have a great rest of your day and weekend.